Good afternoon, everyone. Welcome to the penultimate session for the day. In this talk, we'll focus on security by default in Anthos. I don't have a demo, so I can't really blame the Wi-Fi if something goes wrong. Let's see how it goes. So I am Arun Kumar. I go by AK. I'm a technical program manager with Google Cloud, specifically for GKE, container, and Anthos security. For agenda for this talk, we'll start with what are the driving philosophy and principles behind Anthos security. Then we'll dig deeper. On some of the security features. We'll then move on to discussing some best practices from a security perspective for Anthos. We'll finally talk about shared responsibility and how the responsibility for securing the cloud saddles between the provider and the user. Time permitting, finally, we'll have a Q&A. Let's jump right in. What is the philosophy that drives the security work behind Anthos? So we wanted security by default to be the underlying theme. Users should not have to become security experts themselves in their quest to modernize their apps. Our users have sophisticated, pretty advanced, and enterprise-grade on-premise systems. Most of these are for valid business reasons, compliance and regulations being among the chief of them. We want to meet customers where they are. The best of our security capabilities should be able to integrate seamlessly with your existing infrastructure. Finally, at Google and Google Cloud, we take security very seriously. We want our users to benefit from our security culture, which has been battle-tested and has been proven over the years. We also have a strong presence in SIGAuth and Kubernetes Product Security Committee. We started by writing a security white paper for Anthos, where we identified and talk about major security challenges that users face as they migrate from traditional to modern apps. The first among them is about enforcing consistent policies across environments. This could be across nodes, across clusters, even across multiple clouds. Anthos helps you solve this problem with ACM. Moving on to the second major challenge, it's a question of how can you effectively secure your software supply chain in your organization and only deploy trusted workloads. The last one talks about securing multi-tenant environments across a shared platform. 2 and 3 we'll address shortly in our talk. I also urge you to take a look at our Anthos security white paper. It makes for an interesting reading. Moving on. So our capabilities are organized across these 5 core security design principles that we have. The first of them is infrastructure security, then supply chain security, and runtime security. The fourth one is configuration and policies. The last one is compliance and certifications. We will only talk about the first 3 in this talk. We already discussed configuration and policies in the ACM talk in detail in the morning. Compliance and certifications, that's a whole big topic unto themselves, and they require more than half an hour by themselves. Moving on. Let's start with a feature deep dive, and with infrastructure and network security. So workload identity, which is in beta, addresses the problem of how you can access GCP services from within your Kubernetes and GKE workloads. Earlier, users faced an impossible trade-off between security and usability. If you wanted to access seamlessly GCP services and resources, you either had to forego principles of least privilege, or you had to deal with burdensome config, rotating credentials, and so on. So with workload identity, we built a completely new IAM primitive called identity namespaces. So what it does is it takes your Kubernetes service account identity and binds it with a Google Cloud service account identity. And once that happens, workloads only have minimal and required permissions, and Google takes care of managing all the credentials, and identity stuff on our side. Moving on, node auto upgrade. This feature keeps your nodes up to date with the most recent and the stable version of Kubernetes. This is particularly important in the context of security patches, right? So if there is a security patch that has been released, GKE automatically patches all your nodes for you. This is available for both COS and Ubuntu. You can also schedule a maintenance window to kind of define when you want these upgrades to happen. Shielded GKE nodes. This protects the node bootstrapping process by anchoring with a VTPM. A TPM is a specialized chip that holds the encryption keys in your machine. A VTPM does the same thing for a virtual machine. When you use this feature, your secrets and your credentials are isolated and protected in this VTPM. Exfiltration becomes super difficult. A node identity is always verified to the cluster. So arbitrary nodes can't steal credentials and then enroll with them by themselves to the cluster. Application layer secrets encryption. We are launching this in GA, I think last week. Please try it out. With this feature, what you do is you take your secrets and credentials, you encrypt them locally on etcd with a data encryption key or a DEC. This DEC is then encrypted by a key encryption key, which you manage and store in Cloud KMS. Cloud KMS, or Cloud Key Management Service, manages these keys for you and also acts as a root of trust upon which you can hold all your credentials. I have a mandatory call out to make here. So by default, Kubernetes secrets are plain text. They are not encrypted, right? What GKE does for you is always and automatically by default encrypt all your secrets. All of them are stored encrypted in disks, and GKE also kind of monitors access for them and so on. This feature is just an additional level of control that we provide you for encryption, mostly for regulatory requirements and if you have sensitive workloads that you want to kind of hold credentials to revoke and rotate and so on. Honorable call out, we also have similar encryption mechanisms where you can encrypt persistent disks along with keys that you manage and you store in Cloud KMS. Let's talk about a couple of networking security features. So network policy is a native Kubernetes feature, right? Most of you would be well aware of it. What this does is it helps you manage pod-to-pod traffic. By default, any pod is visible to all pods within the cluster. The IPs are public within the cluster. So this feature helps you restrict pod-to-pod traffic. Let's move on to VPC service controls. Do you want me to go a little bit slower, or is the pacing right? Okay, I'll take that as an yes. Thank you. So this is one of my most favorite features. VPC service controls enables you to configure security perimeters around your GCP projects and resources, right? So you control the movement of data both in and out of your projects. When the comm lines are secured, data exfiltration, you're protected against data exfiltration from your projects. All data and resource accesses across boundaries are also secured. If your workloads span hybrid environments, for example, worry not, you can use private Google access along with VPC service controls to draw a perimeter around your hybrid environments. Moving on. So this slide actually represents a timeline of the GKE security team's efforts towards hardening the GKE product itself, right, over the years. So as you can see, it started from July 2017, and we have until like 1.15. Interestingly, as a couple of tidbits, if you see 1 and 2, so these are actual vulnerabilities with demonstrated exploits that we secured in time. So this represents a GKE hardening timeline. it's fair to expect that efforts towards hardening our on-prem installations will follow a similar trajectory and pattern. The blue dots represent future launches that we did over the course of time that we are also talking about in this talk. The green dots are implementations of default settings that we've done to reflect best practices that we've advocated in our hardening guides and blogs and so on. So these are available to you by default. I'll just pause a few seconds if you want to absorb the slide, and then I'll move forward. Okay. How do you secure your software supply chain? This is from code, build, test, package, deploy, and so on. You start by using managed base images. Google builds and maintains these base images and scans them for vulnerabilities and automatically patches them. So if you use this, this is available on GCP Marketplace to any GCP customer. It kind of offloads the responsibility of using patched images away from you to Google. This is battle tested, used by Google. We actually use it for App Engine and our own internal products. Vulnerability scanning. Container analysis is the official name. This is a feature that scans all your images in your private Google Container Registry for any known CVE, right? Common vulnerabilities or exposures from the public databases. This works for Debian, Ubuntu, and Alpine images. Once you use this feature, the data, the report that you get from container analysis, you can either use it internally. If you have customers by yourself, you can kind of add metadata to the images that your internal teams use. But most importantly, this lets you prevent those unpatched images from being deployed using binary authorization. This is a super important feature. What it does is it lets you, as an organization, define deployment policies, and it codifies the deployment policies for an entire organization. You can define custom requirements as signatures or attestations, or you can whitelist repositories from which you want images to be deployed. Right? So unauthorized images that either have a vulnerability, that are too old to be valid, that then kind of match up with the attestation, they are blocked from being deployed to any of your installations at the Kubernetes, at the GKE control plane. We use an admission controller for that. At each stage of your CI/CD pipeline in Google, these attestations are checked and re-annotated. Let's move on to runtime security. So GKE Sandbox. This is a very important feature if you run sensitive workloads, or if your workloads have varying levels of risk profiles, right? Earlier, historically, the way you isolate, let's say, sensitive workloads from, let's say, a staging or a developer or a testing workload in your organization is either to stand up new VMs, or in worst cases, even to kind of create new clusters to isolate your workloads, right? With GKE Sandbox, you can achieve isolation on the same node. You can have multiple pods at varying levels of sensitivity and risk running on the same pod, running on the same node. The isolation is at kernel level and at runtime. A plugin there, my coworkers, Tim Allclair, Greg Castle, they are giving a deeper talk on isolation, container escapes, and Sandbox overall tomorrow. So if you're interested, please go ahead and register for the talk. Finally, a brief call out for Cloud Security Command Center. This is a central place on Google Cloud Platform where you can unify, analyze, and view all the security data for your organization. We are also integrated with 5 of these security partners. So if you use any of these 5 partners to augment your security capabilities, all of your tools are completely integrated with CSCC, and the data is surfaced to CSCC. So rounding up Anthos security capabilities, we went over infrastructure security in detail, supply chain and runtime. we didn't get a lot of time to focus on network security. I highly urge you to kind of look at the documentation. They are pretty detailed. Honorable mention, Cloud Armor provides from DOS attacks, Istio server security. We already had Istio in the morning. IAP, I'll talk about it briefly. Master authorized networks lets you accept only traffic from whitelisted IPs. I'll put it up for a few seconds and then move on if you want to absorb it in. Let's move on to best practices. The first one is centralized logging, right? We recommend that you follow the single pane of glass architecture wherever practical, right? Of course, if you have sensitive data, if you have auditable data that you want logged separately, you're always going to segregate it. But having all your monitoring and logging data centralized is of immense value in the case of for security forensics, or even as a way for you to analyze and consume your data. Anthos is well integrated with Google's Stackdriver that you can use as a single pane of glass. Stackdriver also integrates well with Prometheus and Fluentd if you're already using them. The second best practice is about protecting endpoints. This, of course, deserves a separate talk by itself. But the TLDR, I would say, is we would recommend using Cloud IAP or Internet-Aware Proxy that enables a more context-aware evaluation of user's identity or authentication. We also recommend using Apogee for API management if you're operating at that scale. 3 and 4, we already discussed. 3 is about enforcing network perimeter boundaries. This is super critical, especially as your workloads span like multiple clouds or between clouds and hybrid. Enforcing policies and constraints consistently, we primarily do it using ACM. Of honorable mention, spot security policies. If you are a hardcore Kubernetes user, you must be well aware of pod security policy. It lets you define Linux level and like very low level security policies for authorization. We also support gatekeeper and OPA policies via policy controller via ACM that lets you kind of custom create constraints that you want to reflect your business processes. The last one is about isolating workloads in a multi-tenant environment. So Anthos offers features at multiple levels and layers of isolation. 5 of them are here. So if you use GKE private clusters, it gives you private IPs, right? Your cluster is hidden from the internet. Access to master is restricted. GKE namespace is a native Kubernetes construct again. It lets you slice and dice your cluster to reflect your use cases, right? You can create a namespace per app, per user, per team, or per sub-organization in your company, and so on. Network policies, we briefly touched upon it before, but it essentially, the suite of network policies supported offer you fine-grained layer 3 and layer 4 network level access. ASM, or Anthos Service Mesh, on the other hand, provides you service level access, or at an L7 layer. Finally, we touched upon GKE Sandbox, which offers you protection at runtime. So let's move on to the final section, shared responsibility model. So security in the cloud is a shared responsibility between the cloud provider and you, or the customer or the user, right? Broadly speaking, as we move up the stack from infrastructure as a service up to PaaS and then to SaaS, the responsibility owned by the cloud provider increases dramatically, right? And things become easier for you to manage, and your responsibility decreases as you go up the stack. So specifically speaking, if you're using the infrastructure as a service from a cloud provider, the provider is responsible for securing the hardware, the physical machines, the storage attached to it, as well as the network through which you communicate, right? As you move up to PaaS, you get more things out of the box, right? The provider might most likely give you an identity, a full-blown identity system. You'll get data and access management tooling. You'll have auth-in and auth-c constructs natively supported, and a few more features like that, right? If you move further up towards the SaaS layer, it's a really cool operating system there, right? Like most of the stuff by default is managed for you. So the provider manages deployment, even application security, scalability, reliability, uptime, load balancing, the whole suite of them. So GKE or Kubernetes, as you might assume, falls in the PaaS layer, right? So what Google owns and is responsible for is the GKE master, right? The master is completely managed for you. So it is hardened, it is secure, it is protected, and it is upgraded by GKE transparently and completely invisibly to you. You are responsible, A, for maintaining the nodes that you run, the worker nodes where you have deployed your workloads, right? But even here, if you use managed base images that we alluded to a few slides back, and if you opt in for auto upgrade, even this is completely offloaded to Google, right? Google takes care of maintaining these nodes for you. It's completely out of your hands. So what you are essentially left with in GKE is a responsibility for securing your application, your dependencies, and whatever configuration you have. And if you change any of the default config and settings, and then you're responsible for securing the new surface that these updated config open up. So that's about GKE on GCP shared responsibility. When you move to on-prem, and this is applicable for certain other components of Anthos also, as you can see, the shared responsibility model changes dramatically, right? You as a user are responsible for a lot of stuff. So while this means that you have a lot more to contend with in terms of management, this also means that you have more control and more visibility over how you want to define your workloads. So depending on your compliance and your regulations and your existing business infrastructure, I think some of these pieces will move and change, but this is broadly true.